And here we go once again for an episode of Mr. Read Math, where we're going to take some of the mystery in math and make it past tense. And I just wanted to say hi. I hope everybody's doing well. I hope you're dry in this rain soaked week coming up on our first day in a while of NTI instruction. We're going to be followed by 2 more days of NTI instruction. So hang on, hold on to your hats. We're going to cover a little bit of content, get you a little bit of an intro into what's coming, and we're going to do this for 3 days, but we will be back on the classroom on Monday. So, all right, without further ado, let us get to content. We are coming into a section now. We're going to start analyzing perimeter and area. Now, you've explored perimeter before with simple shapes, but we're going to start applying it to all the other shapes and some 3D shapes as well as we go forward. But just to kind of remind you what the two words mean, if I was building a deck onto the back of my house, all right, the area is like the floor surface. If I was going to Lowe's or Home Depot to figure out, how much wood I needed for this project, I'd want to know, how big the surface area of the deck was, and that's how I would determine how many deck boards I needed. But then the other part of that is the perimeter. The perimeter is the area around the outside edge of the deck, and that would be kind of like my handrails. Okay, so think of the perimeter is the area around the shape, whatever it is, and the area is the area in the surface area inside the shape. Okay, hopefully that example kind of helps. We've also spoken of yards and fences and things like that, but I thought the example of a deck with the deck boards being the area and the handrails being the perimeter was a good example for today. All right, so let's begin with probably the first shape that you ever calculated the area for. All right, and this would be a rectangle. All right, nothing special about it other than it's just 90-degree corners. We've got a couple measurements for the base and the side length, but it's just a rectangle. All right, now this unit is actually entitled Parallelograms, and if you think about it, a rectangle is a parallelogram. It's just a parallelogram where all the angles are 90 degrees. Okay, so we're going to start with this one because, like I said, this is probably the first one you ever calculated. And if you remember, the way you find the perimeter is just you count up the lengths of all the outside sides and add them together. So we're going to have two of these. Let's start with the base would be the largest piece. So that would be the base. The base would be 11. So 2 times the base, 2 times 11, that would be 22. All right. And then you got the side pieces. That they're 7 each in this case. So it would be 2 times 7, which would be 14. All right. So you got 22 plus 14, and that would be 36. And that's how you would figure out what the perimeter is for this. Or you can just simply go 7 plus 11 plus 7 plus 11. Both get you the same answer, 36. All right. So the perimeter is pretty simple in that regard. Now, area is going to be expressed in terms of units squared. All right. That's one of the biggest things. We're trying to figure out if this is in feet, then what I'm trying to figure out is how many little 1 foot by 1 foot sections does this whole structure make up? All right, and so there's 11 across this way and 7 up this way. And the way we calculate it, 7 rows of 11, so 7 times 11, the area, the base times the height would be 77. Okay, once again, it was 36 for this and 77 for that. Now, are we always going to call it the base and the side or the base times the height? Honestly, it depends on how it's oriented most of the time. Sometimes people will say width times the length or width or depth times the width or what have you. But the main thing is you got one pair of sides that are parallel and that are congruent because it is a parallelogram, and you got another pair of sides that are parallel and congruent. So 2 sides, 2 bases. All right, let's move on to the next most likely one that you calculated in, I'd guess, 4th grade or 6th grade. And that would be a square. All right. Now we're going to follow the same rules because a square is also a parallelogram. It's also a rectangle. So really nothing's changed. The only difference with a square is that all 4 sides are the same length. All right. So we can get in here and we can say, well, the perimeter, just like on the rectangle, is 2 bases and 2 sides. So 2 times 7 is 14, plus 2 times 7 is 14, 28 would be the total there. Of course, the other way you can look at it, you say, well, Mr. Reed, square has 4 bases all the same length, so why not just multiply the base times 4? Okay, 4 times 7 is 28. Cool, got the same answer. Or, well, Mr. Reed, why don't we multiply the side times 4, since all of them are technically the same as the side? Same thing, all right? However you want to label it, however you want to call it, that's fine. But you're basically taking the total of all of the side lengths to get the perimeter. All right, then the area, spell it right there, the area is, once again, the base times the height. So that would be 7 times 7, which would be 49. And again, you can catch me on a technicality and say, well, Mr. Reed, wouldn't that be the same as if I took the base and squared it? It is a square, haha, get it after all. But so if I took 7 squared, what do I get? 49. Okay, so however you want to calculate it, if it is a square, you can do all these options, okay? But ultimately, just like with the rectangle, it's the base times the height to get the area. And then you're going to express that. I didn't show you this on the last one, but if it was feet, for instance, you would say 49 feet squared. That's the proper way to label it. All right, so let's get a little bit of discipline in us. Let's label it the correct way. When we're labeling the perimeter, we're just measuring the length. We're not measuring little, 1 foot cubes. So that would simply be 28 feet. All right, but when you find the area, it's expressed as squared. All right, let's move on to shape number 3. Haha, the parallelogram. All right, and that's really the name of this unit, and this is the toughest shape to calculate. So what do we do with this thing? I mean, something tells me that if I multiply 10 times 6, that doesn't seem right, all right? And it's not. It's not the way to calculate it. What do we do? Well, if you do a little bit of imagining, you say, well, what if I took a saw and I cut off this end right here? And doesn't it look like it would be a perfectly shaped triangle to just move over and snap into place right here, just like I did in this piece, right? So I cut that off and I slip that piece over there. And if that works, if that happens, and just keep in mind, it's always going to be 2 parallel congruent sides and then 2 parallel congruent sides. That's a parallelogram. So yes, this will work. The angles are the same. It matches up that way. And so what does this shape actually become when we do that? Well, it becomes a rectangle. So we treat it like a rectangle. The height, though, that we're looking for is this length right here. All right. This diagonal length along this side is not the height of our parallelogram. You have to take a perpendicular off of one of the bases to figure out what the height is. Okay, and so that's where a parallelogram is a little bit of a challenge. Fortunately, when we get posed with these types of questions, you're usually going to be given the information you need to know what that height is or to calculate what that height is. All right, so in this case, you might see something like this where you've got a parallelogram drawn and you got this little dashed line here, and that's all that's doing. It's not a piece of the shape. That's just a reference to tell you that the actual height of this object is 5. Okay, so now we've got 3 different numbers that we've got to figure out what to do with. All right, well, if I'm doing the perimeter, nothing really changes with the perimeter. I'm still trying to find out what is the distance to go around the object. Now, if this was 6 miles and you were running a route and you needed to run 6 miles and somebody tried to tell you, no, it's 5 miles, you'd think they're crazy. No, I know that was 6 miles. That's a lot. But so the point is, you need to know if we're taking care of just the outside, you pay attention to that value, not this one. This is kind of an internal calculation, okay? So the perimeter would be 2 of the bases, which would be 10 and 10, and 2 of the sides, which would be 6 and 6. All right, so 10 times 2 is 20, plus 6 times 2 is 12, 20 plus 12, 32. All right, and we'll label it, we'll just stay with feet. All right, now the area is the part, this is why you need this little figure off to the side, because you need to know for the area what the height is. All right, so we're going to take the base. We're not going to multiply the base times the 6. That's not going to be an accurate answer for height. All right, we need to know what this distance is, and it tells us off to the side that that's 5. So 10 times 5, just like we would do with a rectangle, is 50. All right, so the area would be 50 feet squared. Okay, and that takes care of parallelograms. It also takes care of rectangles and squares. We're going to move on to other things tomorrow, but I hope this, like I said, I hope this NTI day sees you well, sees you dry, sees you safe. Please let me know if there's anything you're concerned about or any concerns with your communication with school. I'll do the best I can to help you out, all right? But have a great day, and I will see you hopefully Monday in class. Bye-bye.